When we're analysing the data, it's really important to keep in mind why we're doing it. So in this case, we're analysing this data to see where you might need some professional learning. Normally, when we analyse our student data, it's going to be to determine what things I'm going to need to work on with my class. So I'm going to show you how to do both, and I'll just show you with this data what I would concentrate on. I've now reduced the size of my screen, zoomed into 50% so that I can get all of my data on the one window. Just go up to your controls there. And I've ordered my students in order of scale score from highest to lowest, and in order of question difficulty. And the reason I've done that is so we can do a Goodman analysis, which looks at that relationship between the scale score and the question difficulty. So I've screenshotted that. And you'll notice that I've drawn this red line from bottom to top. Now, in the area above the red line, you would expect to see mostly green. So these are the easier questions and the high achieving students. So you'd expect that to be pretty much all green, as it basically is. We're going to look for some anomalies in this case. And down here, you would expect it to be mostly red. All right, so let's have a look at some of these things that seem a little bit odd to me. I'm going to first come to this reasonably easy question where I've got 3 of my top students getting it wrong, pardon me, and my 2 weakest students getting it right. So that's something, you know, that I find pretty interesting. As we go across to here, this one really looks interesting to me. Of my top 1, 2, 3, 4, 5, 6, 7 students, 5 of them have got it wrong. But then my middle students have got it right, or middle to high students have got it right. So I think there might be something happening in that question too. There's another one here where if you look down here, you can see that my bottom 4 students have got this question right. But my top 1, 2, 3, 4, 5, 9 students, 6 of them have got it wrong. Or let's say 4 of my top 5 students have got this wrong, while 4 of my bottom 4 students have got it right. An interesting question to look at there. I think that'll be enough, those 3 questions, that'll be enough for us to look at. There are other areas where we might like to look, maybe this one, 35. And one thing that I did find interesting was the hardest question. 42% of my students got it right. Look at these top students, all got that one right. Whereas the one next to it, which was 2 points harder, only 13% of my students got it right. So that's a really interesting way of looking at your data. So let's have a look at these questions. All right, what did we say? We said question 18. Right, a scale question, and this doesn't surprise me at all. Just about every school I've worked in, this question is not well done. One of the things I think is really important is this isn't necessarily a measurement question. Yes, sure, it's a measurement question, but it's also a number line question. If students understand a number line, then they're going to be able to understand that it doesn't always go up by ones, and we need to actually work out what each of these marks represent. number 35. $350 times 200. Well, I can tell you what happens. Very good students, certainly at year 5 level, can often be very procedural. They know the rules and they know how to stick to the rules. So, for example, when they see a problem like this, they see that as a long multiplication problem. And so they will do it as a vertical algorithm, 350 times 200. They'll write the 350 at the top times 200. And what can happen then is that they can get confused with all these zeros. What some of the middle students do is use the mental strategies. So they might say 350 times 100 is 35,000. So by 200, it's going to be 70,000. Or they might do 35 times 2 is 70, and there's 3 zeros, 70 and 3 extra zeros. Or they may have some other mental strategy that they can use to solve that. This really highlights the importance of teaching mental strategies to all students, not just your middle ones, not just your low achievers, but everyone. And have the students alternate between these mental strategies and written strategies, and let them know that they can use mental strategies in a test. Oh, calendars. Yeah. It's funny when you click on these, you'll actually notice you go, oh yes, of course. It's really difficult for students. They don't see a lot of calendars. In our digital world, we don't tend to use calendars anywhere near as much as we used to. And also our students these days are very much guided by what they're told. There are 20 more sleeps to your birthday. Just that sort of thing. They're not actually taught the calendar specifically. So it's a visualization question as well as a measurement question, as well as, I mean, it says it's a year 2 question. Whereas some of my, as we saw before, some of my top students got this question wrong. Look at that. 4 of the top 5 students got it wrong. So it is well worth looking at that and having a think about what is contributing to this. Now, I could sit here and flick through my data and tell you all my issues all day, every day, but it doesn't mean anything to you. You need to look at your data. So I'll tell you what I have gained from my data, but then I want you to have a look at yours. So few charts, I realized that while my number isn't too bad, my probability is really good. I really need to look at geometry and measurement. When you've determined your areas for improvement, have a look at the questions, because hidden within those questions are lots of other strands. So for example, we talked about that measurement question where we're looking at a scale, and we said that that's really also a number line. Okay, so it's also really relevant to number. My other point too is that although my number statistics don't seem too bad, there aren't too many questions where more than 50% of the students got it right. So I'd really be looking in depth at some of these questions and look at how I can teach these areas better. What are the underlying mathematical concepts behind these areas, and how can I teach them better? Have a look at the questions that really need attention, because we've got some suggestions for you to attack those. This is a sample of the test 5 item analysis that AMSI schools have done.
And let's just have a look at, say, question 20. Let's look at 18, because that was one of the ones that we struggled with. It's funny because the analysis that we based our school on, noticed that 82% of their students got that right. So to me, that is a problem with my students and therefore my teaching. We've gone a little bit further. We've put the New South Wales stages in. We've then given some suggestions for dealing with this misconception. So we've talked about reading scales and what to do, some suggested activities, then some information, in this case from NZ Maths and from Calculate, a game that can be played. And we've got that for every question. So that enables you to look at the questions that are an issue, have a look at the theory behind them, and some examples of good tasks to use. So you can see we rely a lot on NZ Maths, Enrich, and the AMSI Calculate site. You can also talk to your outreach officer. We'll give you all sorts of other ideas and perhaps set up unit plans and that sort of thing. I think at this point I've covered everything you need to know about the item analysis and what you can do with it. I suggest, as I said, that you play with your data and see what you can find out from it. Please contact your outreach officer if there's any questions. Thanks for joining us for the data analysis. It's been fun for me and I hope it's been fun for you. Good luck with your analysis. Please give me a call or drop me a line if there's any questions, or speak to your outreach officer, and good luck.